Okay, good morning, all. Welcome to the session. So, this is third session for week 3 and final session also. And tomorrow is the deadline for week 3 assignment. Please try to submit as early as possible. Okay, so in today's session, we will start off with two major announcements and then we will solve few problems. Also discussing power of a signal, okay, and power signals. Am I audible?
Yes, sir.
Okay. All right. So the first major announcement is we have released the first assignment, first programming assignment in the MATLAB grader. Okay. So I hope most of you have enrolled into the course, right? Is there anyone who still yet to log into MATLAB grader? Everybody are familiar to MATLAB grader, right? Were you able to see the first assignment?
Yes,
Yes. Okay. Okay, so anyway, I will just show you guys how does MATLAB Grader looks and all, and where you have to write your code and everything. Okay, so once you log in, this is how you see the page. You just have to click on the courses, and if you have enrolled it through mail, then you will get to see the course like this here. So you have to check your mails. So I have invited all of you to this particular course, Signals and Systems Jan 2025. And if you click on that, on the leftmost left top, you will see simulation exercise simulation exercise 1. If you click on that, there are four problems, mainly related to the first two are related to shifting and scaling, and the third and fourth are signal manipulation and energy computation. So click on each of the problem, and you can actually write your code here itself, or you can open this problem in MATLAB online website. It will redirect you to that MATLAB online page, or you can write your code here and then just run this function, and you can check your validity of time axis and signal values. Like, I think those are the two things were asked in this particular problem. So once you are okay, satisfied, everything is running smoothly, you can just click submit. Unless you do submit, it won't be get saved. Okay, and you can submit as many number of, it's almost unlimited number of times. Okay, so the final one will be taken and it will be graded. And coming to the frequency, your first assignment will be, or it is released with week 4, right? So the next assignment will be released along with week 6 contents. Likewise, 8, 10, and the final assignment, fifth assignment, will come along with the 12th week, the last week. Okay, and the deadline for each of the assignment will be, or the time window will be for 2 weeks. If at all there is any change, we will let you know. Okay, so as of now, the tentative dates are like this. Is this okay? If you guys haven't signed up into MATLAB Grader, please do it, because first assignment has already been released. I saw still there are 35 people yet to log in. I'm not sure one of you. I'm not sure whether all of you have come in or not. So we have sent mails. Even in the G space, we were reminding you. Okay, so please do log in. So at the end, don't tell us that we didn't inform you. So we have informed you in all possible ways. Okay, so that is one thing. And the next thing is there is a slight change in grading policy. I will also share my screen and let you know what that is. I hope my new screen is visible. As of now, the grading document stands like this. So you will be having uh, majorly three components. So the first component is your graded assignment submissions and it carries 10% of the weightage. And the next component comes from quizzes and NTERM. And the last component is the GRPS which you will be doing. So we will be releasing 5 assignments on MATLAB Grader and we will take the best 4 out of the 5 assignments. Right. So the change is actually there is an in-person lab which will be done after this term. So during May or something. Okay. So now what we made is even we made that compulsory. So you have to come to IIT Madras in person to perform that lab experiment. And that lab component, this will be done in person. And this will carry 5% of the weightage. Okay, so in-person lab will be conducted in IIT Madras. And this will be 5% to your total score. Okay, and not only that, this is actually mandatory exercise to be done. So that means if this component, if you didn't attempt, your score will not be, your final score will not be out and you will not get the grades for this course. Okay. And if we are adding 0.05, we should reduce 0.05 somewhere, right? And that we are doing it on final exam. So your final exams will not be 0.5F or 0.4F. They will be 0.45 and here 0.35. Okay. So in the final component, we are reducing 5% and we are just adding it to the lab component. Okay. But there is some relaxation on this. So as I said, this in-person thing, if you are interested to come in person to IIT Madras, then you can come. We recommend you to come in person and do it because if you come to in person, grades will be in our hand. Whereas you will have some relaxation that, let's say, if you are not able to travel to IIT Madras or you are unwell or if you have any other personal reasons where you are unable to travel, so you can do this lab component online also. and this will also be released in the month of May. Okay, but you have to do any one of these things, in person or online. So that's the only relaxation you have. But what we suggest is, if it is online, it will be auto graded. Okay, so there is no partial markings or there is no variability. So if your all test cases passed, you will get full marks. If you are unable to pass all the test cases, then you will get partial marks. Whereas in in-person labs, so if you come here and perform lab in front of us, there is a high chance that even though your code didn't run completely, but you are able to explain or show us the results, then there is a high chance that you will get good scores. Okay, so that's the change, and we will send an mail regarding this updated grading policy, and we will also post it in the GSpace. We will also paste it in the discourse forum. Okay, so these are the two announcements that I would like to address here. Let's come back to week 3.
Hello, sir.
Yes.
So, so what we have to do in lab? It is the MATLAB coding or something like that.
Just now I said, right, what we you have to do in the lab, in-person lab, is it?
Yes, yes, in person lab.
So in-person lab, we will be giving you a series of assignments, like again the same math lab only, nothing else.
MATLAB,
And
no MATLAB.
yeah, math lab only.
Okay.
And if you have done this 5 assignments, that will be like a combination of those 5 assignments in some sense. Okay. All right. So let's come back. So the next thing I wanted to discuss in today's session is, we will solve a couple of problems, and after that we will discuss what a power signal is, what a power of a signal is, and then what are power signals, and solve the last problem. Okay. So this is the problem 1 for today. So what we have to do in this problem is, we have to compute the energy of even part and odd part of the following signal. Okay, it's not that energy of this signal, rather you are asked to compute the energy of even part of the signal and energy of odd part of the signal. For this, what we have to do is, as a first step, can we directly use the formula? Okay. So what we have to do is, we have to first draw or compute the even part and the odd part of this particular signal. How does the even part look? Come on, whatever you are thinking is correct. This is not that difficult to say.
Will it be same?
Yeah. So if you stare at the signal, how does it look? Is it symmetric to?
Yes, it is symmetric.
Correct, right? So if it is symmetric to y-axis, what does the signal? What is the signal?
It's even.
Even. So what you have to do is, even though the question might be confusing, asking for even part and odd part, sometimes just stare at the function or the graph given to you and see whether the given graph is even or odd. If it is not even or odd, then you have to split this into even and odd. Let's say, since this is easy, now if at all you have to compute the energy of even part and odd part, even part will just become the energy of the signal itself, and odd part energy will be, how does odd part of this signal look? Yeah. Tell me, how does odd part look? If the whole signal is
I think
even,
it will be 0, right?
yeah. So this will just simply be the zero signal. And what is the energy of the zero signal?
It would be 0.
Correct. And if I have to compute the energy of even, what should I do? I have to integrate from minus infinite to infinite. What should I integrate? What is energy of a signal? Right? Magnitude square. And magnitude here, the signal is real. So magnitude doesn't play any role. It's just what absolute value, modulus. And you are just squaring it. What we need is basically x of t. Right? So if I write x of t analytically, how does the expressions look? What is x of t? It's a triangle. Right? What is x of t? X of t is only defined or non-zero in between -1 to +1, and in the other interval it is simply 0. Therefore, when t is between -1 to 0, so this interval, how does x of t looking? It's like a straight line with some slope. Right? What is the equation of this line? So it is passing through -1 comma 0 and 0 comma 1. Yeah. Is it okay? So is it t -1 or
I think so. T plus, yes, T minus.
t -1 or t +1? Just no, I'm quite surprised here. So I expected at least one of you will tell this. But what is the
Yes,
equation of a line that passes
T
through
plus 1, sir.
t +1? Correct. How do you do it? So there are 2 points, -1 comma 0 and 0 comma 1. So the slope is
Y2 minus Y1 upon X2 minus X1.
y minus. So you can do that also. Y2 minus y1 divided by x2 minus x1, where y2, so you can also write it x1 y1, x2 y2. So the slope m is 1 minus 0 divided by 0 minus of -1, which will give me 1. Now the slope is 1. I have 1 point. If I write the equation of the line, y minus 1 is equals to, so I'm choosing this point and this slope. What is the slope? This is just point slope form. So y minus y1 or y2 into slope, which is 1, times x minus x2, which is 0. So you'll get x plus 1. Okay, so I have done this explicitly, but these are all expected from you. Okay, so this will be t plus 1. Now, how is my signal looking in the interval 0 to plus 1. This one. Again a straight line.
Minus t.
Sorry.
Y is equal to 1 minus t.
1 minus t. Very good. So this will be 1 minus t in the interval 0 to 1. And in other intervals,
0.
it will be 0. So now this is what we have to substitute in place of x of t. So what we will do is we will ignore the 0 part because the integral of 0 is 0. So this will be down to minus 1 to plus 1. But even minus 1 to plus 1, I am just splitting it into 2 because my x of t is different in those two intervals. So minus 1 to 0, my x of t is t plus 1 and whole square dt plus integral 0 to 1, my x of t looks like 1 minus t whole square dt. So these things you have to do. So from here it is just computation. So expand, simplify, get the answer. Okay, so now I'm not going to do this. What I want is the final answer from you guys. Okay. So solve this quickly and we can move to the next problem. You just have to integrate. Everything is available to you.
So it's accounting for 0.
0.
Ah,
Okay, let me wait for others also.
uh, 2 by 3. I'm sorry.
So, okay, anyway, I'm not going to solve this, but the answer will be 2 by 3 because it is just a shift of triangle. It's actually triangle. And energy of a triangle is 2 by 3. Okay, so you guys can solve that. Okay, so if at all, let's say the curve okay, if it is given like this, and we are asked to find the energy of even part and odd part. Now, what we have to do? Firstly, you have to draw the even part and odd part carefully, right? So, what will be the even part of this signal? Come on, you guys should be able to do this. So week 3 is all about computing even bar, dot bar, finding periodicity, energy and power. And these are very, very important also. Anyone? Okay. Hint is, if you are too confused about how triangle will become, how to compute the even part or odd part of a triangle, compute the equations. So once you have the analytical expressions, then computing even part and odd part are easy. Or you have one more thing also. Draw x of minus t, and then you can observe something, right? You add x of t to x of minus t and divide it by 2. How does the graph look? And you subtract x of t and x of minus t and divide it by 2. How does it look? So those will be your even part and odd parts. Okay. And if you solve, if you draw the curves, it will more or less look like this. This will be your even part. This will be your odd part. And once you have this even part and odd part separately, now what you have to do is you just have to compute the energy. Okay, so find E even part, energy of odd part. And once you find energy of even part, you can observe here that energy of odd part will also be
0. No, no, 0.
there is a square here. Okay, so you see a square term here.
Yeah, equal. Yeah, equals to or part energy of even.
Ha. So there is no need to compute the energy of odd signal once you have the energy of even signal. Okay. So in this case, okay, so I'm not doing this again, but you can do this. So sometimes questions may not be directly asking for energy of the given signal. So just be careful what we are asking. So if we are asking you to compute the energy of even part and odd part separately, then what you have to do is you have to draw the even part and odd part, then write the analytical expressions, then substitute them in the formula. Okay, so that is how you have to do. Now let's go to the problem 2. In problem 2, we have also discussed in the last live session about the period and periodicity. So this problem is on that, and you have a kind of similar question in the graded assignment also. Okay, so find the period of the signal z of t, which is actually equal to cos 9 pi t plus sine 30 pi t. Okay. Yeah, again, I will just give you guys 2 minutes to solve, and then we will discuss the answer. And usually, at least in my live sessions, I expect people to interact. Because you see, this is an online format, right? Like, I'm not sure if it is an offline class. I know I can see your faces and I can sense at least how many of you are getting it, how many of you are not getting it, something like that. I can actually assess. Here, being online and we are all turning off our cameras, I'm not sure how many of you are actually doing this or how many of you are just joined and just left. Okay, so for that, pretty soon I will come up with some metrics. Maybe I will just put some polls in between so that those who have attempted the poll, maybe they were, maybe I can think of like they were active. Or at least, if you don't want me to do that, at least just unmute, try to speak. If you get the answer, just let me know. Or just raise the hand that you are done, or just type it in the chat that I am done. So something like this, these something like these things will tell me, at least partially tell me, that you are actually understanding this or doing this. Okay, is that clear?
Yes, sir.
Yeah.
So in this part, we will first find the capital T in this, and then we take the LCM. It's
Hmm.
easy.
Okay. So what will you get? So the thing is, so if you have sum of two cosines, you know the frequency of the repetition of this signal, right? Or the time period. So what is the time period? T1 cos 9 pi t.
2 pi by 9 pi, so it will be cancelled 2 by 9, T1,
Hmm.
2 by 9.
So it will be 2 pi by 9 pi. 2 pi by omega. Those who know will know that time period is actually 2 pi by omega. Right? So this is 2 by 9. Similarly, what is this? What is the time period for this? Again, the same
1
thing.
by
2 pi
15.
by 30 by 30 pi. 1 by 15. Now I have 1 by 15 and 2 by 9. So this function repeats every 2 by 9 intervals, and this function repeats every 1 by 15 intervals. Right? So this is 2 by 9, 2 by 9, 2 by 9, 2 by 9. Like this, cos 9 pi t will repeat. Whereas sine will be like 1 by 15. Right? 1 by 15, 1 by 15, 1 by 15, 1 by 15. So sine 30 pi will repeat like this. But what we want basically is when this one and this one aligns. So something like at the start, both will begin. And what is the first place where again both will uh, complete the rotations, complete the cycles in some sense. So in order to find this, what you have to do is, it is basically the LCM of this 2 by 9 and 1 by 15. Right? If I do, what will I get?
In denominator, it will be 45, and then the numerator, this will be like 30 and 10 or 3, and then we will take the LCM of those number, and it will be
Hmm.
become 30, and the time period will be like 30 by
2 2 by
45. 2 by 3 it's become
2 by 3.
2
3.
by 3.
Correct. So I have to multiply. some integer to this and some integer to this, so that they both will be equal. Okay. So if you do that, you will have, if you multiply 3 to this, and if you multiply 10 to this, what will you get is both will give you 2 by 3. So what does this mean is, you do 3, you take the 3 time periods of this signal. So like this 3 time periods, and within these 3 time periods, our sine 30 pi will do 10 cycles. 5, 6, 7, 8, 9 and 10. And after 10th cycle and after the third cycle, this will again meet. This will meet for the first time. Okay, so therefore, the total time period of the sum signal will be 2 by 3. Okay, so you just have to do, you just have to compute the period like this, and period of 2 sinusoids you can compute like this. Okay. So any doubt here? Now you can solve graded assignment questions also. Okay, so most of the graded assignment questions are on what are the even part and odd parts and computation of energy, and there are few problems on how to compute the period of the signal.
Sir, what is average power means? Uh,
Average energy.
yeah, there is in graded assignment one question regarding the average power.
Average power.
Yes.
Can you let me know which question is that?
I think question number 4 or 5. Correct?
Just a second. Question number 4.
Yeah.
Graded assignment 3.
Yeah, graded assignment the question number 4 or 5, I think. So
Okay, so what is the mathematical representation for the average power of the signal x of
yeah,
t?
I think it should be
The
power.
power of the signal. Yeah, it is power of the signal. It should be power. It is power of the signal actually.
Okay. So we have to answer.
Yeah. According to the power, take it as a power of the signal. Okay. Okay. So let's finally finish this by discussion on simple discussion on what power of a signal is and which signals are called power signals. So sometimes the energy of the signals may be infinite, right? So not every signal will have finite energy. And the simple example we know is u of t, right? The unit step function. So if you try to compute the energy of this signal, the signal looks like this, and it's the magnitude square and area under the magnitude square. Even the magnitude square of the unit step signal will be the same unit signal itself. And if you see carefully, the integral actually computes area under this curve, and this will go to infinite, so area under this curve will also be infinite. So such signals may have some average energy in some time period. So that is called power of a signal. So mathematical expression of power of a signal is you compute the energy in some time window. In the time window minus t by 2 to t by 2, and you take the average of that energy. Okay, which is nothing but whatever the length you considered, you divide it by that length. So that will give you the average. And what you do is you tend that t to infinity. Okay, so initially we consider in this interval and compute the average energy. And then you compute the average energy in this interval. And like this, you compute the average energy of the signal from minus infinite to plus infinite. And that will give you the power of the signal. So that is nothing but your initial, that is nothing but this expression. Your initial t starts from maybe here, minus t by 2, maybe here. And then slowly you move this t to infinite. You tend this t to infinite. So that will give you the average energy of the signal, right? That is nothing but power of a signal is. And if your energy is finite, okay, energy is finite implies if your signal is an energy signal, then the power is 0. So the power of energy signals are zeros. Okay. So energy signal will not have any power. Whereas if your power is like if you compute the power and it is greater than 0, then definitely your energy is infinite. Okay. And also again, strong note that if your energy is infinite, it doesn't imply that your power is finite. Or you can't guarantee that your power will be some real number. Okay. So the only things are if it is an energy signal, then the power is 0. If it is a power signal, then the energy of that signal is infinite. And signals with finite power are called power signals. So once you compute this and you are getting some real number, then the signal corresponding to that x of t is called the power signal. Okay. So now how do you compute the power of a signal? We will just use formula. If you're okay with formula, just use formula. Let's compute power of this u of t that we just discussed. Okay, so the power is you have to tend your capital T to infinite 1 by t minus t by 2 to t by 2 magnitude x of t whole square dt. And if you see our u of t in the interval minus t by 2 to plus t by 2, it will be 0 from minus t by 2 to 0, and from 0 to t by 2 it is 1. So therefore this will be limit t tends to infinite 1 by t will be as is. Now our limits will get updated to 0 to t by 2 because from minus t by 2 to 0 it will just be 0, and from 0 to t by 2 it is 1 dt. Now this is limit t tends to infinite 1 by t. If I integrate, I will get t, and the limits are t by 2 0. If I substitute, I will get 1 by t limit t tends to infinite 1 by t into t by 2. I'll get half independent of t now. capital T now. So therefore, this will also stay as half. So the power of an unit step signal is half. Right? So let's do one more problem. Let's say our x of t is e power minus mod t. Okay, so let's see what will. So what do you think it should happen? X of t e power minus mod t. How does this signal look? Okay, if you have modulus inside it, just try to remove that modulus.
So
How
it's
does
like
this look?
if t will be less than 0, then the signal will be e to power t. And if t is greater than 0, then it will be e to power minus t.
Correct. That's it. So if you write it explicitly, what will it be? E power, it will be e power minus of minus t when t less than 0. It will be e power minus t when t greater than or equals to 0. And what is this? E power minus of minus t will give us
E power
e
t.
power t. So how does e power t look when t less than 0?
Yeah, it is a continuously increasing function from infinity to 1 minus infinity to 1.
Correct, right? So this is how it looks. Now, how does e power minus t look when t greater than or equals to 0?
Decreasing function is
Decreasing
from
function
1.
starting from 1. So
1.
something like this. So this will be our x of t. And this is t. Now, looking at the graph, what do you think? Well, compute. So let's compute energy and power. So what will be the energy?
Energy should be infinite.
Energy should be finite, and I think it is 1.
So when you compute energy, this is again minus infinite to plus infinite mod x of t whole square dt. And again, you have to split this interval, complete interval to minus infinite to 0. And here it is e power t dt plus this is 0 to infinite e power minus t dt. Right? So when I integrate now, I will have e power t, and the limits are 0 minus infinite plus.
Here it would be
Find.
e to power 2t, right? Because it is getting squared.
Right. So 2t. So this will be e power 2t by 2. This will be e power minus 2t by minus 2. And the limits are infinite and 0. If I substitute, I'll get e power 2 times 0 divided by 2 minus e power 2 times minus infinite divided by 2 plus e power minus 2 times infinite by minus 2 minus e power minus 2 into 0 divided by minus 2. Now what will happen? This will go to 0. This will go to 0 because they are e power minus infinites. And e power minus infinites will go to 0. And what will happen to this? This will be half. And this will also be half. Which will give me 1. So once I have my energy finite value, what will be the power?
0.
0. Correct. So you don't have to sit and solve this thing. Even if you solve, you'll get 0. At the end, you'll get 0. But the easiest way is computing energy is very easy. Or if you plot, you will see that area under this curve, if you square it, what will happen? Again, if even though you square the exponential curves, it will just be exponential only. Right? It will just be scaled. But it will have the same kind of shape. And you can easily observe that this thing will be finite. Right? Once this is finite, because these are coming close to zeros. Okay, so once this is finite, energy is finite, then the power is 0. No need to compute. So from this, if your energy is finite, it will become energy signal and it will not be a power signal. Okay. All right. So finally, let's compute the power of a periodic signal. Okay. So let's take a signal which is periodic. Okay. So this will go this way. This will go this way. So this is t. This is x of t. And let's say this is minus 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Minus 2, minus 3, minus 4, minus 5, minus 6, 7 and so on. Okay. And this is 1. This is 2. This is 3. Okay. So now this signal, if I try to compute energy, what will I get?
I think infinite energy is.
Infinite energy, right? Because you will have this. If you square this will become 4 and that will become 9. And you will have infinite non-zero area under the curves, which will give you infinite energy. So once energy is infinite, you are little bit sure that there is a chance that this could be a power signal. Okay, so now how do I compute? You can use the formula, no issues with that. But once you take t, so if you fix this t interval, it will not be consistent that much. So once if you consider minus 3.5 to 3.5, okay, and the next time you consider this thing, So your integrals or the components of the signal will not be consistent. But there is an easy way. If your signal is periodic, so this computing period becomes very, very easy, because computing power will become easy, because power of a periodic signals is just simply computing the average energy in one period. Okay, so that will give you the power of the periodic signals. So what do I mean by that is, so you have your energy, right? So what is the energy? Minus infinite to plus infinite. Right, so this you have. But if I compute the energy in some time period, this will be either you can start from minus t by 2 to plus t by 2, or you can start from 0 to capital T, right? But you just have to pick one period. And then what you have to do is you take the average of that energy. This will give you power. Okay. So yeah, here capital T is the time period. Okay, you consider one time period, any time period. You can start from, so here what is the period firstly? Let's fix the period first. So what is the length of the period? Or what is the fundamental period of the signal? Oh my god. Anybody? Okay, so how do you compute period of the
Srijit,
signal?
7.
Hmm. So what you have to do is, the easiest way to do is you choose a point randomly choose a point. Okay. So let me choose this 2.2. You see the signal, how the signal is behaving. So this is the signal, this is how the signal is, right? You move right or left, and you move till you see the same part of the signal again. So when is it repeating again? So you started from 2, move, and when you reach 8, your signal will repeat back. Right? Correct? Yeah. 3, 4, 5, 6. Is this periodic? It should be periodic. Oh my god, what is happening here?
I guess the period should be 6, no, sir?
But when you start from here, it is repeating here. Yeah, it should be 6 only. Okay. So this I matched it up. So let's say this is, I have given 2 units for this. Rest everything has 1 unit. So this should start from 0 to 1. Okay. So ignore this part. This is 0 to 1 and this will be -1, -2, -3, -4, -5, -6. So now you can see that this particular signal is periodic and the period will be 6. So you start randomly at a point and you look at the signal and go towards right or left till you get the same kind of shape back. So you started from 2 and after 6 units to the right, you will get the same kind of shape. So 8 minus 2 will give you the period. So the period is 6. Time period is 6. So fundamental period T, capital T is 6. So now what you do is you take capital T to be 6 and you compute, you take any interval, like you start from 2 to 8 or you start from 0 to 6. It doesn't matter. You should take in one period and you just do 1 by 6 times, let me take from 2 to 8. Okay, 2 to 8. So from 2 to 8, what you have? X of t whole square dt. So from 2 to 8, you see our signal has amplitude 2 in the interval 2 to 3, amplitude 3 in the interval 4 to 5, amplitude 1 in the interval 6 to 7. And 3 to 4, 5 to 6, 7 to 8, it is 0. So that means this will be simply 1 by 6 integral 2 to 3, it is 2 square dt plus, and 3 to 4 we don't have anything. 4 to 5 we have 3 square dt plus 6 to 7 1 square dt. That's it. Okay, so you compute the integral and divide it by 6, you will get a finite value of the power. Some finite value, which will be the power. So in periodic signals, so the conclusion is in periodic signals, you don't have to consider the original formula like limit t tends to infinite 1 by t minus t by 2 to t by 2 and these things. Rather, you can compute the average energy in one time period. And that time period you can choose. That interval you can choose. So it should be like one particular time period. Okay. So with that, I think week 3 we have stopped. In week 4, we will start with some effects. So what will happen to the energy and power if we shift scale and do the reversal? These things. We'll start off with that and we will also deal very important signal, useful signal in all the LTI systems also, and even in signals and systems course itself, which is Dirac delta, which we'll see in the next week. Okay.
Okay, sir.
Yeah. Okay, then that's all for today. We'll meet next week.
Thank you, sir. Sir, this regarding and small query regarding that